Hello everyone. In this lesson we're going to look at the fundamental theorem of calculus, just a different way for us to be able to find the area underneath a curve and on a closed interval. So we have here theorem 4.9, the fundamental theorem of calculus. If a function f is continuous on the closed interval from a to b, and capital F is an antiderivative of f on the interval a to b, then the antiderivative of f of x dx from a to b is equal to the antiderivative evaluated at b minus the antiderivative of f evaluated at a. So in other words, we want to integrate or find the antiderivative of the function and then evaluate that antiderivative of the upper limit and then subtract that from the evaluation of the antiderivative on the lower limit. Okay, so here we're going to evaluate these definite integrals, and our instructions ask us to use a graphing utility to verify, which is not required. So the first one we have here is 6x dx on the closed interval from 0 to 2. We want to find the antiderivative of 6x dx on the closed interval of 0 to 2. All right, so 6x dx, the integration or antiderivative of that, add 1 to the exponent and divide by that new exponent. If we simplify that, that gives us 3x squared. Now we want to evaluate this thing from 0 to 2. So the first thing I'm going to do is evaluate it at my upper limit of 2. So 3 times 2 squared minus the evaluation of the antiderivative on the lower limit, minus 3 times 0 squared. Now to simplify this, we'll just use our algebra skills. 2 squared is 4, 4 times 3 is 12, 3 times 0 is 0. Therefore, the integration, the antiderivative of 6x dx from 0 to 2 is equal to 12. Okay, on this next one, we have the function t squared minus 2 dt. We want to evaluate the antiderivative of that function from negative 1 to 1. So again, we will find the antiderivative of t squared minus 2 dt. So the antiderivative of t squared dt is t to the third divided by 3. Add 1 to the exponent and divide. The antiderivative of 2 dt is simply 2t. Now we will evaluate this function on the upper limit, and then we will subtract the evaluation of the lower limit from this. So we'll evaluate the antiderivative on the upper limit, which is 1. So 1/3 is 1. 1 to the third power is 1 over 3. 2 times 1 is 2. Minus, now we're going to evaluate at negative 1. Negative 1 to the third power is negative 1/3. Minus 2 times negative 1 gives us plus 2. So now we have 1/3 minus 2 minus negative makes plus 1/3 minus 2. And it might be helpful to go ahead and convert those 2's into thirds, so we will have common denominators there. So 6/3 here and 6/3 here. And then we can quickly simplify that. 1/3 minus 6/3 is negative 5/3. Plus 1/3 is negative 4. Minus 6 is negative 10/3. Okay, let's take a look at this next one here. We have the function of 2t minus 1 squared dt. We want to find the antiderivative of that from 0 to 1. So the first thing that we want to do is to multiply the 2t minus 1 squared. We want to multiply that out, 2t minus 1 times 2t minus 1. Or we can use that old algebra that we learned that says a minus b squared is equal to a squared minus 2ab plus b squared. The first term squared minus 2 times a times b plus the last term squared. So a squared, let's write this up here. A minus b squared is equal to a squared minus 2ab plus b squared. So with that information, that means I'm going to integrate from 0 to 1. I'm going to rewrite this by expanding it out to make it 4t squared, the first term squared, 2 times 2t times 1 minus 4t plus the last term squared, so plus 1. And then I will just find the antiderivative of each part, each term there. So now I have 4t to the third divided by 3 minus 4t squared divided by 2 plus t. And this will be evaluated from 0 to 1. So if I evaluate this thing at 1, I have 4 times 1 to the third power. 1 to the third power is 1. So I have 4 times 1 to the third power over 3 minus, we know that that's 2. 4 divided by 2 is 2. So 2 times 1 squared plus 1. Now if I evaluate this at 0, you see that each one of these terms, I have 4 times 0 divided by 3. 0 divided by 3 is 0. 4 times 0 divided by 2, 0 divided by 2 is 0, plus 0. So if I evaluate this thing at 0, it would just be 0. So in this one, I'm only concerned with my upper limit. So I have 4 thirds minus 2. So let's go ahead and make that into 6 thirds plus 3 thirds. That 1, let's change that to have a common denominator, change it to 3 thirds. And then 4 minus 6 is negative 2, and negative 2 plus 3 equals 1/3. So I see here that the evaluation of 2t minus 1 squared dt, the antiderivative of that evaluated from 0 to 1, is equal to 1/3. Okay, let's look at another one here. Number 15, we have u minus 2 over the square root of u du evaluated from 1 to 4. So we want to find the antiderivative of u minus 2